Hi, I'm Sean Gannon, and this is Minute Math, and today we're learning about the mean value theorem for integrals.
Minute Math, when you need help you use Minute Math.
We're given this problem right here. F of x equals a negative x squared minus 2x plus 5, and we have to evaluate or find the average value of the function on the interval from negative 4 to 0. So we're going to use our formula here, our f of c, the average here, f of c. They tell us that it's 1 over b minus a, so the b value would be 0, 0 minus a negative 4 at a, from the integral from, well, a to b, so negative 4 to 0, of our function, negative x squared minus 2x plus 5 dx. Okay? And then from here, well, we need to just solve this, right? But pretty easy. 0 minus a negative 4 is plus a positive 4, so we have a 1/4 out front. Now we're going to take the integral here of negative x squared minus 2x plus 5, and we get a negative x to the third over 3 minus x squared plus a 5x. And we're integrating this from, well, 0, or negative 4, sorry, to 0. Okay? So we're integrating this from negative 4 to 0 there. Okay? And we're going to go plug them in. So we're first going to plug in 0 in for x, then the negative 4. So 1/4 stays out front here. When we plug 0 into our integral here, it just comes out to be a 0. We subtract that, and then we have to find, well, we plug in negative 4 in for x, and when I plug in negative 4 in for x for all of this, I got a negative 44 over 3. Well, we can simplify this pretty easily. We have a 1/4 here times, well, 0 minus a negative 44 over 3 is a positive 44 over 3. Multiply that out. 1/4 times a 44 over 44 over 3 is 11/3, which also equals a 3.6 repeating. And so there we have it. We found the average value of the function on our given interval, and that was an 11/3. We're given this problem right here. F of x equals a negative x to the fourth plus 2x squared plus 4. And we want to find the average value over the interval from negative 2 to 1. Well, our rules tell us here we have our formula for the mean value theorem for integrals. So let's go find f of c, the average value there. And they tell us it's 1 over b minus a. b being the 1 here, minus the a value, a negative 2, okay, on the interval. Then we multiply that by the integral here from negative 2 to 1 of our function negative x to the fourth plus 2x squared plus 4 dx. Alright, so now that we have it set up, we just gotta solve it. Okay? So 1 minus a negative 2 is plus a positive 2, so we have 1/3 out front here. Taking the integral here of negative x to the fourth, we have a negative x to the fifth over 5 plus 2x squared becomes a 2x to the third power over 3. Then integral of 4 is 4x. And we're integrating this from negative 2 to 1. Okay? So I keep plugging it in. We have 1/3 out front. We now plug 1 in for x. And when I plug 1 in for x in my integral, I get I did the work for you, 67 over 15. We subtract when we plug a negative 2 in for x, and when we plug a negative 2 in for x, we get a negative 104 over 15 again. Alright, so now we're going to simplify this. Well, 1/3 stays out front. 67 over 15 minus a negative 104 over 15, or plus a positive, right, comes out to be a 57 over 5. 1/3 times 57 over 5 comes out to be a 19 over 5, simplified, which equals a 3.8 as a decimal. Let's keep it as 19 over 5 as my answer here, and so the average value of our function over our given interval is a 19 over 5. We're given this problem right here. F of x equals a negative x squared over 2 plus x plus 3/2. And we have the interval from negative 3 to 1. And we want to find the value of c that satisfies the mean value theorem for integrals here. So first thing I want to do is find my average value, my f of c. So to do that, I have my f of c here is equal to, using the formula, 1 over b minus a, so 1 minus a negative 3, on the integral from negative 3 to 1 of my function f of x, negative x squared over 2 plus x plus 3/2 dx. Now we'll solve this right here. 1 minus a negative 3 is plus a positive 3, so we have 1/4 out here. We have to integrate our function here. So we have a negative x squared over 2 comes out to be negative x to the third over 6, plus, well, x is a x squared over 2, plus 3/2 is just a 3/2 x. And we're integrating this from a negative 3 to 1. So our rules tell us here we're going to plug in 1 first and for x, and when I did that, I plugged 1 in for x and simplified, I got 11 over 6 here, minus when I plug negative 3 in for x, I got a 9/2, positive 9/2. So keep going, we have 1/4 here is equal to 11/6 minus a 9/2 came out to be a negative 8/3. And when I multiplied that out, I got a negative 2/3. And remember, that whole negative 2/3 is equal to my f of c here. Okay? So now that we have f of c right there, negative 2/3, we need to, well, find the value c that satisfies it. So what we're doing is we're plugging c in for x, and we're going to set it equal to, so it says equal to negative 2/3. The way I like to see it like this, let me make a little line here. F of c is equal to my function negative c squared over 2 plus c plus 3/2 is equal to what we found, that negative 2/3. And now this is just an algebra problem that we're solving for c. So to do that, I have to get it equal to 0, so I added 2/3 of both sides, and I have a negative c squared over 2 plus c plus 3/2. Oh, sorry, not plus 3/2. I'm adding a 2/3 of both sides. And when I added 2/3 of both sides, what did I get? 13 over 6 is equal to 0. So at this point, I used the quadratic formula to solve this. I said c is equal to a negative b value 1 plus or minus the square root of b squared 1 squared minus 4 times my a value, negative 1/2, times my c value, 13 over 6, all over 2 times my a, negative 1/2. Okay? So this becomes a little tricky here, all right? When I simplified this out, I ended up with a, what did I get? A negative, oh, sorry, let's go positive because it'll simplify to the end. You should know how to simplify this. 1 plus or minus the square root of 16 over 3. Now, this as a decimal, right, as approximately a plus or minus 3.309. Now notice one of these values is outside of our interval, right? The positive 3.30, oh sorry, positive 3.0, not plus or minus, positive 3.309 and a minus 1.309. Plus or minus would both be out of the interval. So I got approximately a positive 3.309 and approximately a negative 1.309 there. The positive 1 is outside the interval, the negative 1 is inside the interval, so I ignore the positive 1, and so my final answer here is a negative 1.309, approximately right there. So that is the value of c is approximately, that satisfies the mean value theorem for integrals here. We're given this problem right here. F of x equals 4 over x squared on our interval from negative 4 to negative 2, and we want to find the value of c that satisfies the mean value theorem for integrals. So first let's use our formula to find f of c. F of c equals 1 over b minus a, so negative 2 minus a negative 4, times the integral from negative 4 to negative 2 of our function 4 over x squared dx. Not too bad so far. Now, 1 over negative 2 plus or minus a negative 4 or plus a positive 4 is a 1/2 here. And the integral of 4 over x squared comes out to be a negative 4 over x. And we're integrating this from negative 4 to negative 2. So keep on going here. I'm going to plug negative 2 in for x first into my function here. And when I do that, when I plug negative 2 in for x, I get a positive 2. When I plug, now I subtract by plugging negative 4. When I plug negative 4 in for x, I get a positive 1. Well, pretty simple, 1/2. 2 minus 1 is a 1. And 1/2 times 1 is a 1/2. And that's equal to my f of c value, don't forget it. So now we have f of c is equal to 1/2. But we want to find the value of c. So, kind of start over here. I take my f of c. What is it equal to? I plug c into my function here. 4 over c squared is equal to, we found it's equal to a 1/2. Okay? Pretty simple here. I now cross multiply, and I have an 8 equals c squared. Take the square root of both sides, and c is now by itself equals plus or minus the square root of 8. Square root of 8 simplifies to be, well, c equals plus or minus 2 square root of 2. And now I want to check which one's within my interval. And the positive value is not, right? Our interval's from -4 to -2, and clearly positive 2 square root of 2 is outside of it. So our c value equals a -2 square root of 2, which as a decimal comes out to be approximately a -2.828, which again confirms it's in our interval. And so my final answer here, the value c that satisfies the mean value theorem for integrals, is a -2 square root of 2. We're given this problem right here. F of x equals a -x to the third plus 7x squared minus 11x plus 3. And we're given the interval from 1 to 5. And we want to find the average value of the function over this interval. So first I'm going to use my formula, my f of c here. Is equal to 1 over b minus a. This is for the average here. Okay. 1 over b minus a, so my b value is 5, my a value is 1, integral from 1 to 5 of my function, -x to the third plus 7x squared minus 11x plus 3 dx. So now from here, we want to simplify and integrate. So we 1 over 5 minus 1, which is 1/4. And we're multiplying that by the integral here. Now we integrate this function here. -x to the third is a -x to the fourth over 4. Plus 7x squared is, 7x to the third over 3. Minus 11x is 11x squared over 2. You get the gist. And 3 is a 3x. And we're integrating this from 1 to 5. Okay? Alright. So now our process, we need to plug in 5 and then 1 into our function here. Now, hopefully you know how to do that and you've practiced your algebra, so I'm going to give you the simplified answer here. 5 goes into x of our function and we get a fraction of 155 over 12. Subtract that by, we plug 1 into our function here, and I got a -5 over 12 for that. What does that simplify to be? Well, the 1/4 stays out front. And we have a, 155 over 12 minus a -5 over 12, which is plus a positive, so we're adding them. Came out to be, what did I get? Oh, not equal. We're multiplying here. I got a 40 over 3. Well, 1/4 times 40 over 3 comes out to be a 10 over 3, which is equal to, not approximate, a 3.3 repeating. And there we have it. Our average value of the function over the given interval is a 10/3. We're given this problem right here. f of x is equal to a -x to the fifth plus 3x to the third power. And we want to find the average value of the function over the interval from 0 to 1. So let's use our formula here for f of c. Well, 1 over b minus a, b being 1, a being 0 here, times the integral from 0 to 1 of our function, -x to the fifth plus 3x to the third dx. Not too bad to set up. You can do it. Well, then from here, let's go, we'll do it over here. I'll simplify that. 1 minus 0 is 1 over 1, which is just 1, right? Put that 1 out here for right now, but I'll get rid of it in a minute. And then we have to take the integral of our function here. -x to the fifth is a -x to the 6 over 6. Plus, and then 3x to the third is a 3x to the fourth over 3. Oh, sorry, over 4. Over 4, Shad, not 3. 3 would be silly. And then we're integrating this from 0 to 1. Okay? Well, like I said, don't need to multiply times 1 here. So what we're going to do is we plug 1 in for x first. Plug 1 in for x, and I got this simplified to be a 7 over 12. And then we subtract when we plug 0 in for x here, and that came out to be a 0. Well, hopefully you can see this now. We have a 7/12 as an answer here, and as a decimal, that's equal to 0.583, and the 3 is repeating. And that's it. Not too bad here. If you need help with algebra, you should hopefully know how to do that. But our final answer here is the average value of the function is a 7/12. over 12. We're given this problem right here. F of x is equal to 4 times x to the 1/2 power on our interval from 0 to 3. And we have to find the average value here. Well, our f of c, our f of c value here is equal to, actually let's put it below. I like to set it up below first. We want to find that f of c value. And we use a formula, 1 over b minus a, my b value being 3, and my a value being 0, times the integral from 0 to 3 of our function, 4x to the 1/2 dx. You set it up, that's half the battle right here. Now let's go simplify. 1 over 3 minus 0 is 1 over 3. Right? Times the integral. Now, we have to integrate this. 4x to the 1/2 power simplifies or integrates to be an 8/3 x to the 3/2 power. And we're integrating this from a 0 to 3, right there. Okay? So our rules for, well, this integral, we plug in 3 in for x first. So we plug 3 in for x, and I did this for you, and I got a, well, I'll write it out here because it's pretty simple. 8/3, as you can see, times 3 to the 3/2 power. Subtract when we plug 0 in for x, and that is a 0. Okay? Simplifying this out, right, we don't really need the minus 0. Kind of cross that off here, and multiply that by 1/3, and this actually simplifies to be, when it's all said and done, an 8 square root 3 over 3, and hopefully you know how to do that. And that's approximately a 4.619. And so there we have it. We have our answer, our average value over the given interval, which is this 8 times the square root of 3 over 3. We're given this problem right here. F of x is equal to x to the 5th power minus 2x to the 3rd plus x. And we're given the interval here of -1 to 0. And we have to find the average value on that interval. So our formula tells us that f of c is equal to 1 over b minus a, 0 minus a -1, that being the a value, on the integral interval of -1 to 0, a to b, of our function, x to the 5th minus a 2x to the 3rd plus x dx. Alright? We've set it up. Let's go, well, simplify this. 1 over 0 minus a -1 plus a +1, so we just have a 1 up front. Multiplied. Brackets here. The integral of x to the 5th minus 2x to the 3rd plus x is an x to the 6th power over 6 minus an x to the 4th power, integral of this part, over 2, right? Plus a last part integral, x squared over 2. And we're integrating this from a -1 to 0. So from here, we want to follow our rules. Multiply by 1, don't really need it. Plug 0 in first into our equation. When we plug 0 into this equation, you get a 0. Subtracted by, when we plug in -1 in, and I simplified this for you, -1 in for our function here, simplified to be a 1/6. So 0 minus a 1/6 is a -1/6, which is equal to a -0.16 repeating. So our final answer here for the average value of the function over the given interval is a -1/6. We're given this problem right here. F of x equals 1 over x on the interval from 2 to 3, and we want to find the average value of the function over this given interval. So to do that, we want to find f of c. Our formula tells us that it's 1 over a b minus a, so a 3 minus a2 on the integral from 2 to 3 of our function, 1 over x dx. Well, 1 over 3 minus 2 is just a 1, right? 3 minus 2 is 1, got it. Times the integral here. What's the integral of 1 over x? And that's the natural log absolute value of x. And we're doing this from a 2 to 3. I'm going to write my brackets here. So let's go plug it in. A rule state, we plug in 3 first, so we have the natural log of 3, don't need the absolute value because it's a positive number, minus natural log, plug 2 in for x, right there. And that's actually, you can write it like this, natural log of 3 minus natural log of 2. This is approximately a 0.405 if you want the decimal. But there we have it. Our final answer here for the average value of the function of the interval, pretty simple, natural log of 3 minus natural log of 2. We're given this problem right here. f of x equals x to the fifth power minus 4x to the third plus 2x minus 1. And we want to find the average value of the function over the given interval from negative 2 to positive 2. Well, we first want to use our formula here. So let's go find our f of c. F of c is equal to 1 over a b minus a, b value being 2, a value being negative 2. And then we multiply that by the integral from negative 2, the a value to the b value, positive 2, of our function. X to the fifth minus 4x to the third plus 2x minus 1 dx. So then from here, well, let's go simplify this and solve it. 1 over 2 minus a negative 2 is 1 over positive 2, or 2 plus a positive 2, so it's 1/4, times the integral here. Now we want to integrate our x to the fifth, so x to the fifth is x to the sixth over 6 minus 4x to the third integrates to be a x to the fourth, plus 2x is x squared, and then minus 1 is minus an x. And we're integrating this on the interval from negative 2 to positive 2. Okay. Right out here. I'll put the 1/4 out front. And what we want to do is we're going to plug in 2 in for x first. When I plug 2 into my x values here, I got a negative 10 over 3. Then we want to plug in a negative 2, and for our x values, I'm going to subtract that value. And when I plug negative 2 into my integral function here, I got a negative 2/3, or positive 2/3 actually. We're subtracting it. So now I have a 1/4 times negative 10/3 minus a 2/3, I simplified to be a negative 4. And you can see that where this is going. 1/4 times a negative 4 is a negative 1. And so we have our answer. Our average value of the function over the given interval is a negative 1. We're given this problem right here. F of x is equal to a negative x to the fifth power plus 4x to the third minus 5x minus 3. And we want to find the average value of the function over the given interval from negative 2 to 0. Well, first we want to find f of c, that's the average there. So we use our formula, 1 over b minus a, b being 0, a being a negative 2. Integrate that from negative 2 to 0 of our function. Negative x to the fifth plus 4x to the third minus 5x minus 3 dx. So let's go simplify this. What does it come out to be? Well, 1 over 0 minus a negative 2 is plus a positive 2, 1/2. Multiply that by, what's the integral of negative 5x? And that's a negative x to the sixth power over 6. Integral of 4x to the third is just x to the fourth. Integral of negative 5x is minus 5x squared over 2. And then minus 3 is a minus 3x. And we're integrating this on the interval from negative 2 to 0. Okay, a lot to unpack here. 1/2 stays up front. Multiply this by, we first want to plug 0 into our function, the integral we found here. When I did that, when I plugged 0 into this function, I got, well, pretty easy to see is 0. I love when zeros are there. Makes it easy. We subtract that when we plug negative 2 in for x. So I'll leave the simplification for you if you need it, but I did it for you. Plug negative 2 in for x, and I got a positive 4/3 when it's all said and done. So now we just have a 1/2 times a, well, 0 minus 4/3 is a negative 4/3. And 1/2 times a negative 4/3 is a negative 2/3, which is a negative 0.6 repeating. And so we found our answer. Our average value of the function over our given interval was a negative 2/3. We're given this problem right here. F of x is equal to x to the fifth minus 2x to the third minus 2 on the interval from negative 1 to 1. And we want to find the average value of the function over the given interval. Well, I want to use my formula, f of c here. They tell us that f of c is equal to 1 over b minus a, b being 1, minus a value, negative 1. We then integrate from that interval, negative 1 to 1, of our function, x to the fifth minus 2x to the third minus 2 dx. Well, 1 over 1 minus a negative 1 plus a positive 1 is a 1/2. So we have 1/2 right here. We're going to multiply that by the integral of our function. X to the fifth is an x to the sixth over 6 minus 2x to the third is an x to the fourth over 2 minus integral of 2 is a 2x. And we're integrating this from -1 to 1. Well, we have a 1/2 that stays up front. Multiply that by here. Plug 1 in for x. When I plugged 1 in for x already, I got an output of -7/3. Subtract that when I plug in -1 in for x, and I got a +5/3. There. 1/2 stays up front. -7/3 minus a 5/3 comes out to be a -4. Multiply these out. 1/2 times a -4 is a -2. And so my final answer here for the average value of the function over the given interval is a -2. We're given this problem right here. F of x equals a -x plus 2 on the interval from -2 to 2, and we want to find the average value of the function and the value of c that satisfies the mean value theorem. Let's go first find f of c, the average value. Our formula tells us that it's 1 over b minus a, so 2 minus a -2, the a value, on the integral, now, or multiplied by the integral, from -2 to 2 of our function, -x plus 2 dx. Well, let's go simplify this. Let's go find the average value here. 1 over 2 minus a -2 is 1/4, right? That's positive. Multiply that by the integral of -x plus 2, which, pretty simple, is just a -x squared over 2 plus 2x. And again, we're integrating that from a -2 to +2. So then from here, again, simplify, 1/4 stays on here. We plug 2 in for x. Now, while I'm at work here, I did this work for you, and when I plugged a 2 in for x, I got a +2. When I plugged a -2 in for x here of my function, I got a -6. Now we're subtracting a -6, adding a +6, so we have a 1/4 times 2 plus a +6 is an 8. That comes out to be 1/4 times 8, which is a 2. And so 2 is the first part here, and that's our average value of the function. So 2 is the average value of the function over the interval. But now we want to find the value of c that satisfies this. So f of c, plug c into our function here, is a -c plus 2. And we found that that was equal to, right, it was all said and done, a 2. Not too hard to solve here. -c equals, subtract 2 to both sides, and we have a 0. Divide both sides by -1, and c equals 0. And so 0 is the value that, don't forget the u there, that satisfy MVT, the mean value theorem. So our final answer here again, the average value of the function on the interval is 2, and the value c that satisfies the mean value theorem is a 0. We're given this problem right here. F of x equals a -x to the second power minus 8x minus 17 on our interval from -6 to -3. And we want to find the average value of the function over this interval and find the values of c that satisfy the mean value theorem. Well, first I want to find f of c, the average value. So f of c, using my formula, is 1 over b minus a, -3 minus a value, -6, times the integral from -6 to -3 of our function, -x squared minus 8x minus 17 dx. Well, this is actually pretty simple once we have it set up. 1 over -3 minus a -6 is plus a +6, we have 1/3 here. Multiply that. What's the integral of our function? Well, -x squared is a -x to the third over 3 minus 8x integrates to be a 4x squared, and a 17 is just a 17x. And we're integrating this from -6 to -3. Well, rules tell us, we keep the 1/3 down here, we plug -3 first in for x. When I plugged a -3 in for x of our function and simplified, I got a 24. When now we subtract when we plug a -6 in. When I plug a -6 in for x, I got a +30. Well, 1/3 stays out front. Multiply that by 24 minus 30 is a -6. And 1/3 times a -6 is a -2. And so negative 2 is our average value. So this here, so average value of function. That's a negative 2. So we found the first part. Now we want to find the values of c that satisfy the mean value theorem. So what I do is I find what is f of c. Well, our function f of x is right here, so I plug c in for x. Negative c squared minus 8x minus 17. And that's going to be equal to our average value. Remember, this whole thing is equal to f of c. So negative 2. Now we're solving. We have a negative c squared minus 8x. We add a 2 to both sides, and we have a negative 15 equals 0. Now I like to deal with everything. A positive c value up front, so multiply everything by a negative 1. C squared plus 8x plus 15 equals 0. This factors, can't forget factoring in calculus. C plus 5 to be a c and a c plus 3 equals 0. So that gives us two c values of a negative 5 and a negative 3. Both are within our interval here, okay? So, since negative 5 and negative 3 are values that satisfy the MVT, Mean Value Theorem. And there we have it. So my final answer here, the average value of the function on our interval was negative 2, and values of c, really, that satisfy the Mean Value Theorem is a negative 5 and a negative 3. We're given this problem right here. F of x equals a negative 3 times 2x minus 6 to the 1/2 power on our interval from 3 to 5. And we want to find the average value of the function on this interval and the value of c's that satisfy the MVT. Well, first let's go find f of c, my average. F of c here. Well, f of c, our formula tells us it's 1 over b minus a, so 1 over 5 minus 3, times the integral from a to b, 3 to 5, of our function. Negative 3 times 2x minus 6 to the 1/2 power dx. Well, simplifying this, 1 over 5 minus 3 is a 1/2. Multiply that, what's the integral of our function? Negative 3 times 2x minus 6 to the 1/2 power. This comes out to be a negative 2x minus 6 to a 3/2 power. And we want to do this from 3 to 5. Well, 1/2 stays up front, multiply it out here. And we plug 5 in for x first. When I plug 5 in for x and simplify into our function, I got a negative 8. Minus, when we plug 3 into our function and simplify here, I got a 0. Not too bad. From there, 1/2 times, well, a negative 8 is left over, and that comes out to be a negative 4. So negative 4 is the average value of the function. The first part that we need to find. Well, now we want to find the values of c here. So I want to find, well, take what we know of f of c. F of c here, I'll take my function, plug c into it. Not too bad. Negative 3 times 2 times c minus 6 to the 1/2 power. It's just substituting c in for x. But the average value we found, f of c, is this whole thing. We found to be negative 4. So we now can set it equal to negative 4, and it's just algebra at this point. I divide both sides by negative 3, and I have a 2c minus 6 to the 1/2 power is equal to a positive 4/3. I square both sides to get rid of that 1/2 power, and I'm left with 2c minus 6 equals a 4/3 squared. 4/3 squared is a 16 over 9. I add a 6 to both sides, and I got 2c equals a 70 over 9. Divide both sides by 2, and c comes out to be a 35 over 9, which is equal to 3.8, repeating. So 35 over 9 is the value of c that satisfy the mean value theorem. Right here. Alright? So our two values, our average value of the function is a negative 4, and the value c that satisfies the mean value theorem is a 35 over 9. We're given this problem right here. f of x equals 4 over 2x plus 6 squared on our interval from -6 to -5. And we want to find the average value of the function over this interval and the values of c that satisfy the mean value theorem. First, let's go find the average value here, my f of c. So my f of c is equal to my formula they tell us, 1 over b minus a, -5 minus a -6 being the a value here. Integral from the interval, -6 to -5, of my function, 4 over a 2x plus 6 squared dx. Well, the left-hand side is pretty simple. 1 over, well, -5 minus a -6 plus +6. We just have a 1 out front here, right? 1 over 1. Then I found the integral here for you, and the integral of 4 over 2x plus 6 to the second power in the denominator is a -2 over a 2x plus 6. So the first power, so just 2x plus 6. And we're integrating this from -6 to -5. Simplifying that out, we first plug in -5 in for x. When I do that and simplify, I got a 1/2. Plug in -6 in for x here in my function, and I got a 1/3, and we're subtracting them. 1/2 minus a 1/3 comes out to be a 1/6, which is equal to 0.16 repeating. So 1/6 is, you write it here, the average value, if I can write u, of the function. So now we want to find the value of c that satisfies the mean value theorem. So I'm going to take actually what I know here and apply it. f of c is equal to, well, I plug c into my function, right? 4 over 2 times c plus 6 squared. And we found that that f of c is equal to 1/6. Not too bad. So from here we want to solve for c. It's just algebra. Cross multiply, 4 times 6 is a 24, equals a 2c plus 6 here, squared. My 6's and my c's. Square root both sides, and we have a, I'm going to flip it here, well, I'll do it first. Plus or minus the square root of 24 equals a 2c plus 6. Don't forget the plus or minus there, okay? When I flip it around, I'm going to subtract a 6 to both sides, so I have a 2c equals a -6 plus or minus, all right, so I subtract a 6 to both sides. And the square root of 24 simplifies to be a 2 square root of 6, okay? From there, we have, well, I divide both sides by 2, and c equals a -3 plus or minus square root of 6. And now I want to see, well, which ones are within my interval here, and there's only one of them, the c value, the negative. So -6. So -3 minus the square root of 6 is the only one of these two that's within our interval, and that's approximately a -5.449. But I like to write it in the square root form, and so right here is the values that satisfy the MVT, mean value theorem. And so that's our final answer here. 1/6 is the average value of the function, and the value that satisfies the MVT is -3 minus the square root of 6. I hope this video was helpful for you, and if it was, please subscribe to this YouTube channel and like this video. This helps us make more free math lessons for you and for everyone else. So as always, thanks for watching.
Minute Math. When you need help, you use Minute Math.